In this video, we will be beginning factoring by using the greatest common factor and factor by grouping. The first step in any problem where you're asked to factor is always going to be to look for the greatest common factor and remove it first. Now, there may not always be a greatest common factor, but that should be the first thing that you always look for, and do that if you can first. So in this example, I'm looking at all three of these terms and trying to decide if there's some common factor that we could remove from all three. Now remember, factors are things that can divide into these three terms. So I'm looking at the numbers, and I'm seeing a 2, a 4, and an 8. So something that would go into 2, 4, and 8 would be a 2. So I'm going to start by saying at least I've got to pull a 2. Let's look at the variables. This guy has an x squared, this term has an x, and this term has an x. Since everybody has an x, we should be able to pull out at least an x. This one has x squared, which means x times x. So there's two x's sitting here. But these guys only have 1 to give us, so 1 is all we can take. So we're going to take one of those x's. Let's look at the y's. Here we have a y, here I have a y, here I have y squared, which means y times y. But when I look at what do they have in common, I can only take one y out because that's all these two have to give me. If I tried to take this y squared out, I wouldn't have enough here or enough here to make that happen. So we're going to pull a y out as well. So for this example, my greatest common factor for all three terms is 2xy. Now our next job is to put in parentheses what would be left. So if I pull a 2xy out of this first term, what would be left? Well, the 2 has come out, and x has come out. Now there were x squared, or 2 of them sitting there, so that means I'm going to have one x still in there. And the y came out, so that one's gone as well. You remember, we're thinking about this as we're doing the distributive property backwards. So if you were to put this back in, you would have to get this term. So if I took 2xy times x, it would get me back here. Let's do the next one. Now notice there's a minus sign, so we're going to put a minus sign in here. And then I'm looking at 4xy and trying to pull out 2xy. So if I pull the 2 from a 4, that's going to leave me with a 2. Another way to think about this is 2 times what would get me back to that 4 if I did the distributive property. Now the x and the y both came out, so the only thing left in that middle term is a 2. The last term, again, we're going to minus. I've pulled a 2 from the 8, so 2 times 4 would get me back to that 8. I pulled an x, and I pulled one of the y's. Now there was 2 of them sitting there because we had y squared, so that means there's still 1 left. So this would be the factored form by pulling out the greatest common factor. And for this one, that's all we can do. Later we may have other things we can do, but for now this is just us practicing this GCF and pulling it out, and then putting in parentheses what would be left when you pulled that GCF out. Remember, in math, the goal is to always have this line equal to this line. So if we were to simplify this, we should get back to this. We're not making this 2xy disappear, we're just rewriting it in a different form. Let's take a look at example 2. In example 2, you'll notice that I don't have a greatest common factor other than 1. There's nothing that goes into all 4 of those terms. But I want you to notice a key word that I just said there. This one has 4 terms. anytime you see something with 4 terms, you should automatically be thinking this might be a factor by grouping problem. And so we are going to use a technique called factor by grouping to solve or to factor this problem. Now, on its own, factoring by grouping doesn't happen all that often. It's kind of a special case. But later, we're going to use this skill inside of other problems where we've kind of forced this to happen. And so this skill is going to show up again in a more impactful way later. But today, for this video, we're just going to practice this factor by grouping skill. So when you have these 4 terms and no GCF for everybody, what we're going to do is we're going to group these first 2 together, and then we're going to group this second group together and just do the GCFs for each group. So in the first group, I'm looking for the greatest common factor of these 2 terms. So 10 and 12 have a common factor of 2. 2 goes into 10 and 12. And since they both have an x, we can pull an x. Now what would be left? Well, 2 times 5 gets me back to the 10. I've pulled the x out, but there was an a sitting there, so he's still going to be there. 2 times 6 gets me back to 12, and the x has come out. So there's my grouped first 2 terms being factored. Now let's look at the second group. I'm looking for a GCF of these 2. And unfortunately, there's not much I can do here. But remember, there's always one thing you can do, no pun intended. You can pull a 1. Now, it's a positive 1 that I'm pulling out, so I'm going to put plus 1. And if I pull a 1, it's not going to change anything. Now, the goal of factor by grouping is to have this binomial sitting in here and this binomial sitting in here to match, which we have done. When that happens, you can rewrite this as your GCFs in one set and the binomial 5a plus 6, the matchy guys, in the other set. Now, why that works is pretty cool, actually. Think about if you were to simplify this. Now remember, the goal in math is one line has to equal the other line. If we were to simplify this, we would get back to here. You'd take 2x times 5a and 2x times 6. Then you'd take 1 times 5a and 1 times 6. Think about if you were to FOIL this. If you were to FOIL this, you would take 2x times 5a, 2x times 6, does that sound familiar? And 1 times 5a and 1 times 6, does that sound familiar? This is the exact same math as this. It's just a different way of writing it. That second 5a plus 6 has not like magically disappeared. We're still taking 2x times these guys and 1 times these guys. I've just written it in a different format. And so here would be our factored answer. Let's do another grouping problem. Again, I know this is grouping because I'm seeing 1, 2, 3, 4 terms. When you see 4 terms, you're thinking grouping. Let's look at the first group. The first group here is 8a minus 8b. So in that group, I think I can pull an 8, but I don't think I can pull any letters because they both don't have a's and they both don't have b's. So that would leave me with a minus b. Now let's talk about this second group. I think we can all see the 7. And did you notice they both have a's? So we're going to pull a 7a out. But I have a question for you. If I pull a 7a from here, what would be left? Now be careful of this. If I pull a 7a out, I would be left with an a, but he would be negative. If I have a negative a over here, is it going to match this? And so we've got a sign problem. So instead of pulling 7a, what that means I need to do is I need to pull negative 7a. When I pull a negative out, it's going to change everybody's sign. So it's going to make this first term now positive. And for the second term, it was positive. So if I pull this negative out, this is now going to become negative. Now if I pull 7a from there, I'm going to be left with a b. And that then forced this guy to match this guy. If I hadn't pulled this negative, I would have had negative a plus b, and they wouldn't have matched. So, and sometimes you catch this in the beginning. Sometimes you pull like a positive and then go, oh crap, I should have pulled the negative. And that's okay. You can just go back and change it or just redo it. But remember, this guy has to match this guy. So if they match, but everybody's signs are weird, that's the indication that you should have pulled the negative. So then again, the GCF for the first group, the GCF for the second group, make sure you keep that negative sign. And then my matchy guys go in the second group. Again, I didn't have an a minus b disappear. I'm just rewriting it in a different way. I'm still taking 8 times these guys and negative 7a times these guys. But this is the fancy way of writing it in its factored form.